lesson 1 of lesson 1 has how many questions? 1, 2, 3, 4, 5. We're going to all do this in the worksheet that we named L1. Question 2 here has 1, 2, 3, 4. We're going to do all these questions in L2. And then the third question, it has a 1, right, with a lot of data. And we're going to put that in L3. So let's do the first question in question 1. The first thing I'm going to do is I'm going to copy this table to Excel. And when you copy a table to Excel, you want to right click and then match destination formatting. That way you don't bring in HTML formatting. Okay. Now my version of the problem is going to be different than yours. Your problems, this might be 15, it might be 12, it might be 10, it might be 8. Mine happens to be 16, right? So what I'm going to do here is I'm going to highlight 1 and 2. I'm going to grab this little box here and I'm going to drag it down until I get to 16. Okay. And then I'm going to type here, I'm going to type equal 1 divided by 16. Why? Because my sample size is 16. In fact, what I'm going to do here is I'm going to show you good spreadsheet modeling techniques. I'm going to insert a row here, maybe another row. I'm going to type N, and then next to the N, I'm going to type 16. And then down here, instead of typing 1 divided by 16, I'm going to type 1 divided by, then I'm going to click on the cell B1. All right. And then I'm going to put a dollar sign in between the B and the 1. And the reason why I do that is because I want to freeze row 1 here, right? Because I'm going to drag this down. As I drag it down, see what happens. I've frozen this blue box in row 1 by putting a dollar sign in front of the 1, right? And then I can just drag it down for all of them. So this is a uniform distribution, a uniform probability distribution, where there are n possible outcomes, and the probability of spinning a 1 is 0.625. The probability of spinning a 2 is 0.0625. Now, to illustrate that, let's open up this Google Spinner website. I'm going to change the number, the wheel size, to 16. And you can see here that I got 16 spaces. This slice of pizza is the same size as that slice of pizza. So each one of these slices are all the same size. So 1 has the same probability of being selected as 16, right? And then you can spin it. The probability of getting a 5 is barely on the 5 side. The probability of getting a 5 is the area, if you will, this area here divided by the entire circle's area, which is 1 divided by 16, right? The probability of spinning a 9 is 1 divided by 16. The probability of spinning a 5 is 1 divided by 16, right? So all these are equally likely to occur. And the reason why that is, again, because each one of these slices of pizza are the exact same size, same area, right? Okay. So all these values here, these values going to put in here, mine are 1 divided by 16 or 0.0625, right? This is what we call a uniform probability distribution. I'm going to hit enter to make sure I got it right. Now, if this right here is, say, 12, then you would type a 12 here, right? And then you would have 0.0833, and you would delete these here, right? You'd delete those. But I have 16, so I'm going to keep those and change that back to 16, right? Now you want to find out the probability of the spinner landing on an odd number, right? So one way to do that is you can type probability of odd, right? And what I'm going to do is I'm going to type equal 0.625, and I'm going to type equal 0.625 there, right? So equal B4 is 0.625. B6 is 0.625, right? A fast way to do this is to highlight these two, one with equal B4 there and one blank, and then you just drag this down. And this number will show up anywhere X is odd. So X is odd here, X is odd here, odd here, odd here, odd here, odd here, odd here, right? And then this is blank wherever X is even, right? And then I can sum this, right? I can sum this column. And this won't be surprising, right? Because half the numbers between 1 and 16 are odd, and half the numbers between 1 and 16 are even. So 8 of 16 are odd. That'd be 0.5, right? Now, the sum of the distribution is 1, right? The sum of the distribution is 1. But the sum of the probabilities that correspond to odd numbers is 0.5, right? In my case, right? Another way to think about this is the probability of odd equals the probability of 1 or X equal 3 or X equal 5 or X equal 7 or X equal 9 or X equal 11 or X equal 13 or X equal 15. Notice I'm using the word or. When you use the word or, you add, which is why I sum these, right? Okay. So that's the probability of X equal 1. That's the probability of X equal 3. That's the probability of X equal 5. And when I sum these, I'm using the union rule, right? The union rule is where you sum probabilities of mutually exclusive events. And these are mutually exclusive events because I can't spin a 1 and at the same time get a 2. So the probability of 1 and 2 at the same time is 0, right? So these are all mutually exclusive events, right? And when the events are mutually exclusive, you can sum probabilities, right, in the union. Now you want to get the probability of getting a number less than 4, right? The probability of getting a number less than 4 equals what? So what I'm going to do is I'm going to drag this over here. Whoops. I'm going to move this back to there, right? And then I'm going to drag this down to X equal 3. So I got probability of X equal 1, the probability of X equal 2, and the probability of X equal 3. Notice I left this blank because it says what? Less than 4, right? Less than 4 doesn't include 4, right? So all these are empty, right? All those are empty. And then I can drag this over. Again, the probability of X less than 4, the probability that X is less than 4 is equal to the probability that X equals 1 or X equal 2 or X equal 3. And that's the union, right? And these are mutually exclusive, so I can just sum those up. And I get 0.1875. Now, your numbers are going to be different than mine, right? But you can check to make sure you're doing it right by clicking enter, right? By clicking the enter key, by pressing the enter key. Now, you want the probability of getting a number greater than 5, right? So now we want the probability that a number is greater than 5. So I'm going to change this to greater than 5. Now, X equal 5 does not make the statement X greater than 5 true. So we're going to skip over that one. 6 is greater than 5. 5 is not greater than 5, right? So I'm going to type equal, and I'm going to hit enter when I get to column B, right? So this is equal B9. Then I'm going to drag this down. That's the probability that X equals 6. This is the probability that X equals 7. x equal 8, et cetera, right? So the probability that x is greater than 5 equals the probability that x equals 6, or x equals 7, or x equal 8, or x equal 9, or x equal 10, or x equal 11, or x equal 12, or x equal 13, or x equal 14, or x equal 15, or x equals 16. Those are all, that's a union. So again, we can sum those up, right? And we get 0.6875. Another way to think about that is how many numbers between 1 and 16 are greater than 5? Well, I got 1, 2, 3, 4. If I highlight these here, right? And you come down here at the bottom here, you'll see a count, right? How many numbers are greater than, how many numbers are greater than 5? There are how many numbers greater than 5? 11, right? So another way to calculate this probability is I got 11 numbers greater than 5, and I got a total of 16 numbers. And I get 0.6875, the same thing, right? Now this one should be pretty easy. Again, we got the word or here. The probability of getting a 7 and a 4, well, that's 0, right? I can either get a 4 or I can get a 7. I can't land on 7 and 4 at the same time. So again, these two things are mutually exclusive. But this says or instead, right? So when it says or instead, I add the probability of this to the probability of that, right? So what I'll do over here is I'll type equal, and I'll go over to column B. So I'll have equal B7 here. So the probability that x equals 4, well, that is 0.625. The probability that x equals 7 is 0.625. So the probability of 7 or 4, we can just sum those together and we get 0.1250, right? There's two numbers here, right? And they're both mutually exclusive. So another way of calculating that is typing 2 divided by the total number of numbers in the set, right? And that's 16. And I get the same thing, right? 0.250. So 0.0, whoop. Let me just copy it. And then I'll press enter to make sure I got it right. All right, question number 2. We got a Venn diagram here, right? So what I'm going to do is I'm going to copy this diagram. I'm going to copy it to Excel right here. Then I'll shrink it up a little bit, right? I'm going to put a border around it. And I'm also going to do this. I'm going to change the cell color to white. I'm going to choose white here. Okay. Now, the universe is everything in the black square, right? The 17 here is the number of items that are outside of C or B or A, right? So these 17 things are not in C, they're not in B, they're not in A, right? The stuff in A includes these 10 things, these 11 things, these 6 things, and those 8 things, right? The stuff inside of B is 9, 11, 6, and 8. The stuff inside of C is 16, 8, 6, and 8, right? So what I'm going to do here is I got the number of A, the number in A, right? The number in A equals what? 10 plus 11. And your numbers are going to be different than mine, right? 10 plus 11 plus 6 plus 8. 9, 10, 11, 6, 8, right? So the number in A is 35. Okay, the number in B is what? I'll start at the 9 and go clockwise, right? 9, 8, 6, 11. So 9, 8, 6, and 11. right? 9, 8, 6, 11. The number in C is what? I'll start at the 16 and go clockwise. 16, 8, 6, and 8. Sixteen plus 8 plus 6 plus 8. And then I guess O is the white area, right? O is the white area. So I'll type N, and number in O is 17, right? Now I need the number total, right? I'm gonna do a capital N for number total. And I can't sum these up, can I? If I sum these up, then I triple count the 6, I double count the 11, I double count the 8, and I double count the 8, right? So what I'm going to do instead is I'm going to type them individually. So I got 10 plus 11 plus 9 plus 8 plus 6 plus 8 plus 16 plus the 17 that are outside of the 3 circles, right? So I got a total N of 85. So let me just see if I got this right. So I got 35. Let me skinny this up here. So I got 35, and then I got 85 here, right? Whoops. 85 is the total. Let's just press enter to see if we got it right. So those tubes look good, right? Now, this says the number in A, and that's a symbol for and. A and C, right? A and C is this right here, these 6 items are in A and they're in C, right? They're all, these 6 are also in B, right? These 8 aren't in B, but they are in A, right? They're in A and they're in C, correct? So we got 6 plus 8. So right here, I'm going to type number A and C, right? This symbol looks like an N, right? And I just call it and, right? And, or lowercase n. It kind of looks like a lowercase n. And N is the second letter in the word and, right? Okay, so what I'm going to do here is I'm going to add the 6 plus the 8. And I have 14. So there's 14 in A and C. Okay, so now we need to count the number in A and B, and that means to complement. The little superscript thing, that means complement. So things that are not in C. What things are not in C? 6 is in C. 8 is in C. 8 is in C. 16 is in C, right? This is A and B and not in C, right? So that's going to be the number 11. And you can use a superscript C, or you can use a single quotation mark, right, for complement, right? And so this is just the number 11, right? That's just the number 11. Now we got to do the probabilities, right? So what I'll do here is I'll copy these and I'll put them down here. But we want the probability of A. So I'm going to delete these rows. So I want the probability of A and C, the probability of A and B and not C. So I'll change this to a P. I'll change that to a P. And I'll change that to a P, right? And then I'll type equal The number in A is 35, and the total number is 85, right? The number in A and C is 14, and the total is 85. And then the number in A and B and not C is 11, and then the total is 85. I'm going to reduce these to 4 decimal places. I like to have probabilities in 4 decimal places, and then I'll copy these one at a time. Here, here, and here. And I'll press enter. So it looks like we got those all done. Now we have question 3, right? So let me go down here. A bag contains 5 blue marbles. So I'll say blue. Now your number of marbles is going to be different, right? I have 5 blue marbles. I have how many green marbles? 9. And how many red marbles do I have? 4, right? If one marble is drawn from a bag and then put back in the bag, its color is recorded, right? What is the probability of drawing a blue marble and then a red marble? So the first draw, this is the first draw and this is the second draw, right? So the first time through, we have 5 blue, 9 green, and 4 red, right? The second time through, well, if we pulled out a blue, we put it back in, and so we'd have 5. If we pulled out a green, we'd put it back in, so we'd pull out a 9. If we pulled out a red, we'd put it back in, so we'd have 4, right? So this is the first pull, and this is the second pull, right? So we want to know the probability of drawing a blue marble and then a red marble, right? Now the word that and is very restrictive. It's not inclusive. Union or is inclusive. A union is inclusive, right? Union includes everybody. And means you have to meet multiple requirements, right? And so when you're talking about the word or, you're adding mutually exclusive, the probabilities of mutually exclusive events together, right? As we did up here, right? As we did up here. We added 2 probabilities together because the probability of the 7 and a 4 are mutually exclusive in the experiment, right? So we can just add the probability of this to the probability of that. But down here we have the word and. And when you're talking about the word and, you multiply. Okay? So what is the probability of drawing a blue marble, right? So the probability of drawing a blue marble first drawing a blue marble, right, is what? Well, how many blue marbles are there? There's 5. And we're going to divide that by the total. We haven't done the total yet, right? So this is going to be the total. This is the total. And the totals are the same on the first try as on the second try, right? So this is the probability of blue first, right? And then what? And then a red marble. What's the probability of red? Red second. So we got blue first and red second, right? So if we pull out a blue marble first, but we put it back in, we'll still have 5 blue marbles in the bag because we put it back in, right? So given that situation, the probability of pulling a red second is what? Well, it's going to be the number of red divided by the total number of marbles, and that hasn't changed because we put the marble back in, right? Now the probability of blue and then red, so the probability of blue first, let me change this to R, red. We'll call this R2. We'll call this B1. So we're going to pull up a blue first and then a red second, right? So here we have and R2, right? So all we're going to do is we're going to multiply this probability times that probability, right? And we want to limit the number of decimal places to 4. So the probability of a blue one first and a red one second is 0.0617. So we'll double check that by pressing enter. And we got it right. Now, suppose one marble is drawn from the bag and not put back into the bag, right? So there's no replacement. We're not putting it back in. What is the probability of drawing a blue marble and then a red marble? So in this situation, right, I'm going to copy this. I'm going to paste it down here. Here, I'm going to type equal B51 minus 1 because we don't put the marble back in, do we? We're not putting it back in. Up here, we're putting the marble back in, right? Down here, we're not putting it in. Now, that doesn't change the probability of blue being drawn first, but it does change the probability of red being pulled out second, right? And that changes the probability of blue first and red second. And that probability is a 0.654. And the reason why that changes is because we only have 17 marbles in the bag after the blue one's pulled out because we keep this blue marble, we keep it out of the bag. So that leaves us with a total of 17. So we're dividing 4 by 17 here, right? So that changes this probability. Okay. So replacement matters, right? Putting the marble back in matters, right? It changes the probabilities. Now, in a number guessing game, you ask a person to guess a number from 1 to 12. If that person makes a random guess, what is the probability of their guess will be less than 4, right? So the probability of being less than 4, we've already done this problem, right? The probability that X is less than 4, well, that equals the probability of what? That equals the probability that X equals 1 or X equals 2 or X equal 3, correct? And that's just the probability of what? 1 plus the probability of 2 plus the probability of 3, right? Maybe I should put an X equal in there. The probability of X equal 1 plus probability of X equal 2 plus probability of X equal 3. Again, this is an application of the OR rule, right? The union rule. When we're doing a union of events and those events are mutually exclusive, we can just sum their probabilities, right? And so we have a number from 1 to 12, n equals 12, right? The probability of X equaling a number, right? So X, probability of X. So X it could be 1, it could be 2, it could be 3, it could be 4, it could be anything to 12, right? It could be 12. The probability of each one of these, again, is 1 divided by 12. I'll put a $sign between the column letter and the row number. That fixes the row at 57. So all of these will be 0.083333, right? These sum to 1, right? These probabilities sum to 1. And so the probability of X equal 1 or X equal 2 or X equal 3, well, that's just equal to what? The sum of these first three probabilities. Now, another way of doing that is we have 3 values that X can be, 1, 2, or 3. And there's a total of 12 values, right? So then we can just do 3 divided by 12 as well, right? And we get the same thing. So that's just kind of a review of what we did in question 1. Okay, now you are taking the GRE, and the proctor has just announced there is 1 minute left, and you have 7. Now your number of questions left is going to be different than mine, right? I have 7 questions left, right? So let me copy this down here. I'm going to copy this table down here. I'm going to paste it right here, right? What I'm going to do is I'm going to move this down. I'm going to pull this down, right? And there's only 50 test questions, so I'll delete these 2. So how many questions do I have left? I got question 44 to 50, right? That's 7 questions. See right there, 7 questions left. Okay. Now you're taking the GRE, and the proctor has just announced there is 1 minute left, and you have 7 multiple choice questions left. Each question has 4 answer choices, A, B, C, D, right? If I bubble in a B, right? If I bubble in a B, what's the probability I get if I just bubble in all B's on these last 7 questions, right? What's the probability I get question 44 correct? Well, that's just equal to what? 1 divided by 4, right? 1 divided by 4. What's the probability I get 45 correct? 1 divided by 4. What's the probability I get question 46 correct? 47 correct? 48 correct? 49 correct? 50 correct, right? We're going to use this table to find the probability of getting all of the guess questions correct, right? So I want to know that I get question 44 correct, and 45 correct, and 46 correct, and 47 correct, and 48 correct, and 49 correct, and 50 correct, right? Notice the word is and. It's not or, and. So what I have to do here is I have to multiply 0.25 times 0.25 times 0.25 times 0.25 times. So I have to multiply each one of these, right? So I can do it this way. I can do times, 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 and time. I can do it that way, right? I'm going to change this to a number with, I don't know, a bunch of decimal places. Okay. So I can just multiply each one of those. I can multiply all these together, right? Another way to do that is, well, I got 7, right? Well, another way to do that more simply is just to raise it to the 7th power, right? If I raise it to the 7th power, I get the same thing, right? Another thing to do is use a function called product in Excel. What product does, it just multiplies everything in the box together, right? That might be the easiest way to do it in Excel. No matter which way I do it, I get the same thing, right? So the product that I get, the probability that I get all 7 of these questions correct is really close to 0, right? It's 0.001. So this is 0.25. Each one of these is 0.025. The expected number correct is you multiply the number of questions that remain times the probability of getting one of them correct, right? Which is 1 divided by 4. And so the expected number correct is 0.175. 1.75, sorry, 1.75. And it looks like we got 100% on lesson 1, question 1. The next video will be doing the second part of this lesson.